Hey, thanks for clicking on this video. If you want to follow along, the links to the companion worksheet are in the description below. So today we're talking about finding volume using the washer method. Now in a previous video we talked about finding volume, and is the region that we're going to draw is not going to border what we're rotating around. So there's going to be some empty space that we have to take into account. And so what's going to happen is that our cross-section is actually going to be a circle with some empty space taken out of it. And so the way we think about this is we have a small radius here, and then we have a larger radius here. And the area of that is pi big R squared minus pi little r squared. And so oftentimes what you'll see is you'll see the formula written like this. Pi, and then we factor that out, and then we have r squared minus little r squared. All right. So for number 1, we want to find the volume of the region bounded by y equals x plus 3, and y equals 2 squared of x plus 3. Now when x is 0, both of these are at 3. Now the first one has a slope of 1, so it goes over 1 and up 1. That is a line. But the second one is not a line, it's a curve. And the question is, where are they going to be equal? Well, they're the same when x is 0, and they're also the same when x is 4, because 4 plus 3 is 7. Square root of 4 is 2 times 2 is 4, plus 3 is 7 again. And so here is our region. Now for parts A, B, and C, what they differ by is what they rotate around. So for the first one, we're rotating about the x-axis. So when we rotate about the x-axis, what we have is we're going to have a disk, and that disk is going to be centered right here. And so this outer portion of the region is going to rotate around, but then so is this inner portion of the ring. That's all. So inside is going to be empty space. So if I draw this, right here, there's the x-axis. So I need to figure out what's the distance to the inside and what's the distance to the outside. And so the distance to the inside is from the center to here. And so that's going to be this length. So little r is going to be x plus 3. And big R is going to be the distance from here out to the far edge, which is going to be 2 square root of x plus 3. Now, the way these are oriented, they're perpendicular to the x-axis. So the thickness is dx. So the volume of this slice is going to be pi times big R squared. So I'm going to square that. 2 square root of x plus 3 quantity squared. And then minus x plus 3, that's little r squared, times dx. Now that's the volume of just one slice. Now I want the volume of the entire region. So I'm going to add up all those slices from x equals 0 to x equals 4. And I'll put the pi out front. So we have 2 square root of x plus 3 quantity squared minus x plus 3 quantity squared dx. And so there is our integral, which is all we're going to do. If you want to find this integral, you can expand this out or use technology to find it. Now in part B, we're taking this same region, but this time we're rotating it around y equals negative 3. 4, that's 3, that's 7. So negative 3 is down here. And that is what we're rotating about. So now, we always measure our radii from what we're rotating around. So we go from here to here, that's little r. And then from here to the outside, that's big R. Now to find the lengths, what we do is we say, all right, what's this? This is x plus 3. And what is this? This is negative 3. And we subtract them. So that means little r equals x plus 3 minus negative 3. So that's x plus 6. To find big R, we take this up here, which is 2 squared of x plus 3, and then we subtract the bottom. We subtract negative 3. So 2 squared of x plus 3 minus negative 3. We have 2 squared of x minus negative 3, forgot that negative, plus 6. So the volume of this slice is going to be pi. And then we have big R squared, so that's 2 squared of x plus 6 squared minus little r squared, x plus 6 squared dx. Because again, these slices are going to be stacked this way. They're perpendicular to the x-axis, so they're going from left to right. So we're adding them up from 0 to 4. And so we have big R, 2 squared of x plus 6 squared minus x plus 6 squared dx. And there is our integral there. Now for letter C, now we're rotating around the line y equals 8. So we have our line, we have our curve, but now it's being rotated this way. So this right here, now a lot of people, they always get fixated on talking about like up and down, and you can't think that way. The way you have to think about it is from the center, which one is further away? Well, it's going to be this one. So this is what R is, big R. And this is closer, so this is little r. Now to find these lengths, what do? Well, we subtract them. What is this up here? This is 8, and this is x plus 3. This is 8 here, and this is 2 squared of x plus 3 here. So little r is 8 minus this quantity, 2 squared of x plus 3. So this is going to be 5 minus 2 square root of x. Now, big R is 8 minus this quantity, minus the quantity x plus 3. So this is 5 minus x. There is big R. So whichever curve is further away, that's going to be the outside of our solid. Whatever curve is on the inside, that's going to form the inside edge. So the volume of this slice is going to be pi times big R squared is 5 minus x minus little r squared, 5 minus 2 squared of x squared dx. And now when we want to add them up, we're going to add up all these slices from 0 to 4. So put the pi out front, and so we have 5 minus x, quantity squared, minus 5 minus 2 squared of x, quantity squared dx. So there is our integral for that. Next example, here we have the region bounded by y equals x squared and y equals x cubed. So here is x squared, and x cubed between 0 and 1 is actually less than x squared. So here is our region. Now the first one says we're rotating around the x-axis. So this is what we're rotating around here. So from here to here, this is little r. And from here to here, this is big R. So the bottom of this is 0. The top of this is x cubed. The top of this is x squared. So big R is x squared minus 0. And the little r is x cubed. So the volume of this slice is going to equal pi times big R squared. Now it's x squared already, but we got to remember whatever R is, big R is, we ought to square it. And the same with little r squared dx. Okay. So when I add up all of these slices, it's going to be from 0 to 1. So we have x squared squared, and I'm just going to write it as x to the 4th. X cubed squared is x to the 6th dx. There is our integral. Now with letter B, here we're rotating it around y equals 2. So here's x squared, and there's x cubed. Now, if this is what we're rotating around, got to remember, we got to draw a radius from where we're rotating around. So from here out to here, that's the far edge. This is 2. This is x cubed, and that's big R. From here to here, this is 2. This is x squared. This is little r. So little r is, now again, you take the top number minus the bit lower number. This is larger than this. So 2 minus x squared. And big R is 2 minus x cubed. So the volume of the slice is going to equal pi times big R squared. 2 minus x cubed squared minus 2 minus x squared squared dx. And so to get the volume, we add up all the slices from 0 to 1. I'm going to put pi out front. And so we have 2 minus x cubed squared minus 2 minus x squared squared dx. There is our integral. All right, thanks for watching. If you like this video, hit that like button, and if you want to see more, click the subscribe button. To support the channel, click the links down in the description below. Thanks for watching, and remember, the best way to understand something is to do it.